Good evening everyone. Today we are going to understand about the new topic diffraction. So diffraction is one of the property of light which proves that light means the wave nature of light exists. Means that light is a form of wave too. So today we are going to discuss about this diffraction, how it proves that light is a wave nature also. So let's start. So diffraction is the process by which the light or any wave, that may include sound, any electromagnetic waves, etc., they are bent from the corners of the slit and the pattern can be observed on the screen. So we'll understand it through diagram. So now this is a very simple diagram that I have made for you to understand. Remember, this is a diagram only for understanding. It's not actual. So when the light is made to fall on the slit, you can see the slit, the first slit on the left side. When the light and just remember this, that the small slit where the light is passing, the light is moving from it, that slit, the width of that slit must be comparable to the light. Means it must be 10 times or 20 times or 100 times the wavelength of light. It should not be 1000, 10,000 times. Because if it would be a large slit, then you will not observe the same thing. I'll discuss about this later. So first let me discuss about this slit. So when we take the slit with the width comparable to the lambda or the wavelength of the light, then the light, they get deflected, means they get means they bend from the corners of the slit, and the pattern of the light can be observed on the screen. So now let me draw this thing on, means by considering it a wave. So this is what you can see on the screen. This is how the wave travel. Actually, when the slit is comparable to the, means it is comparable to the wavelength of the light, then the light get bend, and the bending of light, means the bending of light, it appears such that it is a wave. So means that in the previous diagram you might have seen that it was just like a circular thing. Means the light were getting bent, and when the light was getting bent, then it was something like a circular. It was becoming circular in shape. So that for understanding we draw it as a wave. So now you might have understood why the bending of light we have made, means why the wave nature of light is proved by diffraction. It's because the light, when the light is passed through the slit comparable to the wavelength of light, then the light gets bent. Okay, so the light gets bent, so the circular, means the circular waves are created. Circular waves, it appears like a wave, circular. Okay, it behaves like a circular wave that is moving in one direction. Now if you had taken larger slit 1000 times, 10,000 times, 20,000 times the wavelength of light, then what would happen? The light won't bend. It would move straight and we would get the straight light on the screen. So this is what will happen. The light would pass straight, because you might have studied in the earlier classes that the light shows the rectilinear propagation, means the property of light, that is rectilinear propagation of light. That rectilinear propagation of light happens when the slit is very large. So this is what happens, and the region on the screen that you can see, on that screen only on one, that the small length, the light can be, means the bright light can be seen. So this happens when the slit is very large. The bright light means the light passes through the slit and it strikes on the screen at a particular point. But in diffraction, the light becomes bent. So let me talk something more about this. What is the pattern formed in diffraction? Because when the slit is very large, then the pattern that is formed, that is nothing. That is just a bright spot in that small region that I have made arrow. In that region only a bright spot will be formed. But in diffraction, something else we will find, that we will understand it. So in diffraction, this is what was happening in diffraction. So now let me explain the wave through a diagram, the bending of light. Then we will come up to the pattern on the screen. The black lines on the wave that you can see, the black lines, that the new black lines that I have drawn, those black lines were the bent light. So just understand this. Isn't it looking the black lines? Don't see the blue lines of the wave. Okay? So the black lines, that they are, don't you think they are looking like a wave? So for the blue wave that is left between both the screen that you can see, the black lines means the bent light that reached the point where the blue wave that I have drawn. At that point, when you consider at first just remove that just think that there is no blue wave. So at that point, just think that the black line that you can see at time t, they reached that point, means they were till the light that were bent, they reached A, B, C, D, E, F, G. At time t, they were at the rays, they were at A, B, C, D, E, F, G. These are the points where the bent light reached at time t. So don't you think that when I join all these points, they become like a wave? They become circular and it looks like a wave. They look like a wave that I have drawn. So the wave, this wave only I was teaching you. This wave only, this means the bent light, they formed just like a circular arc that we call as wave. So the wave that were flowing means the wave that you have seen before, that I was teaching that the waves. So this was the wave that was created. That only so now you might have understood what I was teaching. So the waves are not actually waves, means they are not the waves that are flowing. They are actually the bent light that when we join it, then they appear like a wave. So now you might have understood why we call it as wave nature of light, why the light shows wave nature of light. Now we'll discuss about what is the pattern of light after diffraction. So now just relate both the figure. The first figure means the left hand side figure is the wave figure of diffraction, the slit one. So the middlemost point, the point A forms the brightest image on the screen, and slowly towards the upside and downside, the intensity of the brightness of the light decreases, that you can see in the right figure. So now, so this is the circular image of the diffraction pattern. So now thank you for watching my video, and meet you in the next video.